Hi students, this will be the last coding that you're going to study in this module, okay? Huffman coding. And this coding, one of the interesting aspect of this coding is this is the most important coding of all the other three, okay? Of all the three codings, Huffman coding is the most important, which is regularly asked in the exam, okay? And one of the interesting aspect of Huffman coding is that you can apply Huffman coding to any other coding even other than binary coding, okay? Means not only to binary coding, you can apply Huffman coding to trinary coding or to quaternary coding or any coding. That's one of the interesting aspects of Huffman coding, okay? So let's do the step. The steps are very easy, okay? Just like before, all the steps are very easy. Just simply understand them. So in order to make you understand, what I'm going to do is that as we read each and every step, I will apply those steps in this problem, okay? Here the question is, apply Huffman coding to the source S is equal to S1, S2, S3, S4, S5, S6, which means the value of Q is equal to 6, correct? The total number of messages is equal to 6. Or the total number of source symbols is equal to 6. So source alphabet is this one and code alphabet is this one, right? This is 0, 1, 2, which means this is basically trinary coding, not binary. This is trinary coding, right? 0, 1, 2, 3 code symbols we have to use to code these numbers. And what are the probabilities of these messages? 1 by 3, 1 by 4, 1 by 8, 1 by 8, 1 by 12, 1 by 12, okay? So now this is the question. Now what is the first step? List the source symbols in the order of decreasing probabilities. This is the first step. List the source symbols in the order of decreasing probabilities. If you look over here, already these source symbols are already in the order of decreasing probability. See, 1 by 3 is the greatest and 1 by 12 is the smallest. So these source symbols are already in the decreasing order. So let us list them. I will list them now itself. So I have S1, which is 1 by 3, probability is 1 by 3. S2's probability is 1 by 4. S3's probability is 1 by 8. S4 probability is also 1 by 8. S5 probability is 1 by 12. And S6 probability is also 1 by 12. So there you have it, okay? I list them in the decreasing order. Now, second step. Using the equation Q is equal to R plus alpha into R minus 1. Okay, using this equation, Q is equal to R plus alpha into R minus 1, find the integer alpha. If alpha is not an integer, then add suitable number of dummy symbols of 0 probability to satisfy this equation. Okay, so let's do the second step. So using the equation Q is equal to R plus alpha into R minus 1. So here, let me write that equation. Q is equal to R plus alpha into R minus 1. Okay. So here what is the value of Q? The value of Q is equal to 6, right? Total number of messages is equal to 6. And R, what is the value of R? This is trinary coding, right? 0, 1, 2, 3. So this is trinary coding. So therefore R is equal to 3. Okay. Plus alpha into 3 minus 1 is 2. So what is the value of alpha over here? Alpha is equal to, let me see, alpha is equal to 6 minus 3 by 2, which we have is 1.5, right? 1.5, which therefore alpha is not an integer, which is not what I'm supposed to have alpha as an integer value, but here alpha is not an integer. So if it is not an integer, what am I supposed to do? If alpha is not an integer, then add suitable number of dummy symbols of 0 probability. So therefore, which means that since alpha is not an integer, what I'm going to do is that I'm going to add one more message to my total number of messages, which means here message was 6. So now what I'm going to do is I'm going to add one more message. Okay, I'm going to add one more message to that message is a dummy message and its probability is 0. So that message. So if I add one more message, what will be the value of Q? If I add one more message, what will be the value of Q? The value of Q becomes equal to 7, right? So now let me see what is the value of alpha when Q is equal to 7. So we have Q is equal to R plus alpha into R minus 1. So which is Q is equal to 7 is equal to what is R? R is equal to 3. 3 plus alpha into 2. So therefore alpha is equal to 7 minus 3 by 2. What is 7 minus 3 by 2? 7 minus 3 is 4, 4 by 2 is 2. So which means alpha is equal to 2. So which means that if I put q is equal to 7, I am getting an integer, which is exactly what I want. So therefore in this case, alpha became an integer. And so when is alpha becoming an integer? When q is equal to 7. And when q is equal to 7 is when I add one more message to the total number of message. That message is a dummy message, a dummy symbol, okay, and its probability is considered to be 0. Okay, this is a dummy message. This is not actual message. This is just a dummy. Just for your own purpose of calculation only, we are using this message. That's what it means. Okay, why did I add this dummy message? Because if I add this dummy message, my total number of my value of q becomes equal to 7. And why do I want my q is equal to 7? Because if q is equal to 7, then my alpha becomes an integer, which is 2. See, in this case, when q was 6, my alpha is 1.5, which is not an integer. This is a decimal number. I want a pure integer. So that is why I made q is equal to 7. So this is what it means. This is what the second step means, okay? This step is not required if the coding is binary. You can understand the reason why, right? So if you want to know why, just simply substitute the value of r over here, then you'll understand why. If you put r is equal to 2, then it becomes 2 plus alpha, because here 2 minus 1 is 1, right? So it becomes 2 plus alpha, which is always, therefore you will always get an integer. So there won't be, so this step you can skip if you are applying Huffman coding to binary code, okay? So now next look at the third step. Third step is add the last r symbols into a single composite symbol. Add the last r symbols into a single composite symbol whose probability is equal to the sum of the probabilities of the last r symbols added. Which means here in this messages, here what is the value of r? It's a trinary coding, so the value of r is 3. So what I'm going to do is that I'm going to add the last 3 symbols or the last 3 messages. I'm going to add the last 3 messages, okay? I'm going to add the last 3 messages. Let me add the last 3 messages. Sorry, this is not the last 3 messages, right? The last 3 messages, these 3, sorry. The last 3 messages, this one, okay? Not this. The last 3 message is this one over here, okay? I skipped off this one. This is the last 3 messages, okay? This is the last 3. S5, S6 and S7 is the last 3 messages. So I will add the last 3 messages. So what is 1 by 12 plus 1 by 12 plus 0? 1 by 12 plus 1 by 12 plus 0 is equal to 2 by 12. 2 by 12 is nothing but 1 by 6. Okay. So where is 1 by 6? So that is 1 by 6. Okay. So you see, right? This is what it means. Add the last symbols into a single composite symbol whose probability is equal to the sum of the probabilities of the last r symbols added. So here I'm going to, when I added these 3, I got 1 by 6. Okay. So now look at here. Repeat step 1 and 3. Repeat step 1 and 3. What is 3? What is the first step? First step is decreasing order, right? Rearranging them in decreasing order, and the third step is again adding the last 3 symbols, okay, and keep on doing that until in the final step exactly r symbols are left. So here what I'm going to do is that I added S5, S6 and S7, right? When I added these 3, the last 3 messages I got was 1 by 6. So now I need to put that 1 by 6 in this message such that they are in the decreasing order. So where should I put 1 by 6? We all know that 1 by 6 is lesser than 1 by 4 and greater than 1 by 8, right? 1 by 6 is greater than 1 by 8 and lesser than 1 by 4, which means 1 by 6 should come over here, right? It should come between S2 and S3. So that's where I will put it. So when I added these 3 messages, that is S5, S6 and S7, I got a new message called as sigma 1, and whose probability is equal to the sum of these 3 probabilities, and that is equal to 1 by 6. Okay. Then I am going to rearrange the remaining in the decreasing order. That is, here S1 is 1 by 3, S2 is 1 by 4, and then what is left behind? S3, right? S3 is 1 by 8 and S4 4 is also 1 by 8. See, this is what I meant. Okay, this is what I meant. Adding the last 3 messages, into a single message. So now my new message is sigma 1. Okay, now my new message is sigma 1. Now what is the next step? So the thing is, you should keep doing this step. Okay, that's what it means. All right. Now the next step is assign codes freely to the last R composite symbols and work backwards to the original source to arrive at the optimum code. What this step means that I'm going to assign different values to all the messages that I have added. So what is the message over here? 0, 1, 2, right? So therefore I'm going to assign here 0, I'm going to assign here 1, and I'm going to assign here 2. Okay, 0, 1, 2. Okay, the 3 messages that I have added, I have assigned 3 different codes. Okay, now this is how we do. This is called as Huffman coding. Okay, now if you can repeat the step, we are going to repeat the step till only at the last stage there are only R symbols. Here R is equal to 3, so which means I'm going to keep repeating the step until at the last stage there will be only 3 symbols. Okay, so next is I'm going to add these 3 numbers, right? I'm going to add these 3 numbers, that is sigma 1, S3 and S4. I'm going to add these 3 numbers, and on adding these 3 numbers, what is, let me see, what is 6 inverse? 6 inverse plus 8 inverse plus 8 inverse is equal to what? 5 by 12. Alright, it's 5 by 12. And what is 5 by 12? 5 by 12 is 0.417. 5 by 12 is 0.417, which is greater than 1 by 3, right? Because 1 by 3 is 0.33 and 1 by 4 is 0.25, and this, if I add these 3 numbers, I will get 0.417 or 5 by 12, right? 5 by 12. So therefore that is the greatest, right? That is the greatest. So if that is the greatest, then that should be placed over here. That is the greatest, so that should be placed over here, and the value is sigma 2. Okay, sigma 2, and sigma 2 is, what are the values of sigma 2? Sigma 2 is 5 by 12, right? 1 by 6 plus 1 by 8 plus 1 by 12 is 5 by 12. So 5 by 12, and the rest of them are the same. That is, what we have is S1 as 1 by 3 and S2 as 1 by 4. There. So repeat the step until there are only R symbols at the last stage. And here you see R is equal to 3, right? So here you see the last stage, there are already R symbols. That's it. You have completed your Huffman coding. Then what you're going to do is that you're going to assign codes freely. Right? That's what the step means. Assign codes freely to the last R composite symbols and work backwards to the original source to arrive at the optimum code. So which means here these are the 3 symbols I have added. So I'm going to assign 0, 1, 2 over here. And then I am going to assign this also, the last R composite symbols also 0, 1 and 2. Okay, that's it. This is Huffman coding. So in that case, what is the value of, let me see. Now we'll put the value for everyone, right? So what is the value of S1? You have to read that's what it means. You have to read the word backwards. You have to read the word from right to left. Read the word. So let's see what is here. What is S1? S1 is nothing but 1. So S1 is 1. Okay. What is S2? S2 is 2. Right? S2 is 2. Now, what is S3? Where is S3? S3 is over here, right? And where is S3 coming from? S3 is coming from sigma 2. And what is sigma 2? Sigma 2 is 0. So, sigma 2 is 0 and S3 is 1. So, therefore, S3 is 0, 1. This is the code for S3. This is what it means by reading backwards. Okay? That is here, see, S3 is coming from sigma 2 and S3 is 1 and S3 is coming from sigma 2 and sigma 2 is 0. So it is 0, 1. So the code for S3 is 0, 1. Likewise, what is the code for S4? S4 is also coming from sigma 2 and S4 is 2 and sigma 2 is 0. So therefore the code for S4 is 0, 2. What is the code for S5? The code for S5 is, where is S5? S5 is over here, right? And where is S5 coming from? S5 is coming from sigma 1. And where is sigma 1 is coming from? Sigma 1 is coming from sigma 2. So 0, 0, 0. So S5 is 0, 0, 0. Now next is S6, right? The last message is S6. S6 is coming from sigma 1, which is coming from sigma 2. So therefore sigma 2 is 0, 0, sigma 1 is 0, and S6 is 1. So you have 0, 0, 1. This is the Huffman coding. Okay, this is what you call as Huffman coding. Okay. Now I want you, as a homework, I want all of you to find the efficiency of this code. Okay, I want you all to find the efficiency of this code, the code efficiency and redundancy of this, and say if it is very good or not. Okay. Okay, so now let's do one more problem in Huffman coding. Okay, one more problem. Here the question is the same, except that this time the code is binary. Okay, code is binary. So the first step is listing them in the order of decreasing order of probabilities. Okay, so therefore here it's already decreasing order. So therefore I'm going to write S1 as S1's probability is 1 by 3, S2's probability is 1 by 4, S3 is 1 by 8, S4 is also 1 by 8, S5 is 1 by 12, and S6 is 1 by 12. Okay, this is my probabilities, all right, in the decreasing order. So now here I don't have to apply this equation. It is Q is equal to R plus alpha into R minus 1. I don't have to apply this equation because alpha is always an integer in this case. If you just simply substitute, you will always get alpha as an integer. So which means you can skip this step. Okay, you can skip the step, and then what I'm going to do is that I'm going to add the last two numbers. Why the last two numbers is because this is binary. Okay, so I'm going to add the last two numbers into a single and make it into a single message. So I'm going to add the last two messages. Okay, and so what is 1 by 12 plus 1 by 12? It is equal to 2 by 12, which is 1 by 6. So 1 by 6 means it is between 1 by 4 and 1 by 8, right? So therefore I will put this message over here. Okay, I will put this message over here. So what is now, I'll tell you, my message here is S1 is, sorry, yeah, I'll write over here. Here it is sigma 1, right? Sigma 1 is equal to 1 by 6, right? I got this by adding the last two messages, and here the rest will be the same. That is S1 is 1 by 3, S2 is 1 by 4, and S3 is 1 by 8, and S4 is 1 by 8. Okay, this is the first step. Second step, I'm going to add the last two messages into a single message again. So I'm going to add these two messages. Okay, what is 1 by 8 plus 1 by 8? 1 by 8 plus 1 by 8 is 2 by 8, which is 1 by 4, which means 1 by 4. So that is, so 1 by 4 means I'm going to place it over here. Okay, we should place it above the message. If the value is equal to the message, and then we should place it above the message. Okay, so it is over here. I'm going to place my new message over here. Okay, and its message is sigma 2, and sigma 2 is equal to 1 by 4. Okay, sigma 2 is equal to 1 by 4, and the rest of it will be the same. That is S1 is 1 by 3, and S2 is 1 by 4, and then we have sigma 1. Sigma 1 is 1 by 6. Okay, now what I'm going to do is that I'm going to repeat it again. I'm going to add the last two messages. I'm going to add the last two messages into a single message. Okay, and here what is 1 by 4 plus 1 by 6? What is 4 inverse plus 6 inverse is equal to 5 by 12. And what is 5 by 12 is 0.4. So where should I put this 0.4? Here 1 by 3 is 0.3, right? So that, which means this is greater than that. So which means I should put that first. So therefore, if 1 by 4 plus 1 by 6 is 5 by 12, and that is greater than 1 by 3, so I will place it over here. So which means that is sigma 3. Sigma 3 is equal to 5 by 12. Okay, and then we have the remaining S1 as 1 by 3. S1 is 1 by 3. Sigma 2 as 1 by 4. Okay. Now what I'm going to do is I'm going to add the last two messages again. So by adding the last two messages, what do I get? What is 1 by 3 plus 1 by 4? 1 by 3 plus 1 by 4 is 3 inverse plus 3 inverse plus 4 inverse is equal to 7 by 12, which is greater than 5 by 12, right? It's greater than 5 by 12. So it means 5 by 12 will go down and 7 by 12 will take its place. So this will be like this. This is the last message, and here it is sigma 4. Okay, the new message is sigma 4. Sigma 4 is 7 by 12 and sigma 3 is 5 by 12. See, we are going to keep doing this step until at the last stage there are only two symbols. Okay, at the last stage there are only R symbols. R is equal to 2 over here, so only two symbols. Now what I'm going to do is I'm going to assign 0 and 1 to every numbers I have added. So it means this is 0 1, this is 0 1, this is 0 1, this is 0 1, and this is also 0, and this is 1. Okay, I have assigned it like this. Alright, this is my first step. Okay, so now what I'm going to do is that this is finished. This is my Huffman coding. Now what I'm going to do is I'm going to simply name them, and naming them is from left to right, backwards. Okay, backwards. So let's begin to name them. So first I have S1. What is the code for S1? Where is S1? Look over here. Where is S1? S1 is over here, right? S1 is over here. And where is S1 coming from? S1 is coming from sigma 4. And sigma 4 is 0. So reading backwards, it is 0, 0. So the code for S1 is 0, 0. And what is S2? S2 is, where is S2? S2 is over here, right? And where is S2 is coming from? S2 is coming from sigma 3. And what is sigma 3? Sigma 3 is 1. So therefore it is 1, 0. 1, 0. Okay. What is S3 now? S3 is the code. S3 is over here. And where is S3 coming from? S3 is coming from sigma 2. And where is sigma 2 is coming from? Sigma 2 is coming from sigma 4, which means sigma 4 is 0, sigma 2 is 1, and S4 is and S3 is 0. So it is 0, 1, 0. Okay, see, S3 is coming from sigma 2, and sigma 2 is 1, and sigma 2 is coming from sigma 4, which is 0. So 0, 1, 0. Now what is the code for S4? Code for S4, where is S4 is coming from? S4 is coming from sigma 2. And where is sigma 2 is coming from? Sigma 2 is coming from sigma 4. So sigma 4's code is 0, sigma 2's code is 1, and S4 is 1. So it is 0, 1, 1. Reading backwards. Okay. Now what is the code for S5? The code for S5, where is, now look for S5, where is S5? S5 is over here. So where is S5 is coming from? S5 is coming from sigma 1. S5 is 0, right? And it is coming from sigma 1. And where is sigma 1 is coming from? Sigma 1 is 1, and it is coming from sigma 3. And where is sigma 3 is coming from? Sigma 3 is coming from here, which is 1. So therefore it is 1. Okay. And then here also it is 1 again. Let me see. I think I made a mistake. Let me see. As sigma 3 is 1, and 1 is coming from here, which is 1 again, and which is also 1. Okay. Correct, right? Correct. So it is 1, 1. S5 is 0. Okay. Next is S6. Where is X is? S6 is over here. S6 is coming from sigma 1. And sigma 1, and sigma 1 is coming from sigma 3, and sigma 3 is 1, sigma 1 is also 1, and S6 is 1. So therefore it is 1, 1, 1. This is the code for, this is the Huffman code, okay, for this number. As a homework, I want you all to do find the code efficiency of this Huffman coding also, okay. So with this we have completed Huffman coding, okay.